Okay, intro says that the slow and sloppy 7 got their car back and realized the new tires really helped with gas mileage. They found they could travel 62 miles and only use 2 gallons of gas. The tank of the car holds 15 gallons of gas. So the question number 1 says, what is the gas mileage of the car? Or how far can the car go on 1 gallon of gas? Well, we know we can go 62 miles on 2 gallons. So how far can we go on 1 gallon? Well, 1 is half of 2, so half of 62 must be 31 miles. Okay, we could actually also set that up as a proportion where we could say that we have 62 miles and we can go 2 gallons will give us that 62 miles. We didn't know how many miles up here, but we were looking for that 1 gallon. And again, we could do the same thing. How did we get from 2 to 1? We chopped it in half. So how do we get from 62? Since we chopped this one in half, we have to chop 62 and a half. And we now know that this is 31 miles. So what we just did was we solved a proportion. So what is the gas mileage of this? This car can go 31 miles per gallon. Next question then says, how many miles can they travel on a full tank of gas? Well, if they can go 31 miles per gallon, and we have 15 gallons of gas, we're going to go ahead and just multiply those two together. 31 times 15 is 465 miles. Okay, that one we really didn't have to set up a proportion, and I did throw that one in there because we are working with proportions. Could you have set up a proportion? Yes, but just understanding what we are doing there, much quicker to go that route. All right, moving on. Next stop, Lincoln, Nebraska. The map they are using says each 1/2 inch represents 80 miles. The distance between Pierre and Lincoln on the map is about 2.5 inches. So question 3, how many miles is it between Pierre and Lincoln? Well, we can do this a couple ways. We know 1/2 inch represents 80 miles. So we know that 1 inch, since we really don't like dealing with halves, equals 160 miles. Okay, so we have 1 inch down, another inch gives us another 160 miles, and we have to add 1/2 inch in there, which we know gives us 80 miles. So all of that together, 160 plus 160 is 320 plus 80, grand total of 400 miles. Miles of 400. Again, let's look at what that would look like as a proportion. We know that 1/2 inch represents 80 miles. What I just did was I set up a ratio. I'm comparing inches to miles. Now what I'm going to do is I'm going to look at that ratio and I'm going to set it equal to my 2.5 inches. And I don't know how many miles that is. So last time we looked at how these numbers compared. 2.5 inches is 5 times as much as 1/2. So that's what we're going to do down here. What is 5 times the amount of 800? 400 is. So 2 different ways that you could look at this. Both of them give me the same answer. Again, this piece right here is the ratio because I'm comparing 2 numbers. As soon as I set that equal to another ratio, I have a proportion. Also notice something else, that I kept this organized, that I was comparing inches to inches, I was comparing miles to miles. If I flip this 400 miles and the 2.5, my proportion would not be equal. Okay, last question here states that gas is $3.50 a gallon. So how much should they budget for gas for the round trip? Well, round trip means there and back. So we know that it's 400 miles there, and then round trip, that means that we have to go 800 miles. Well, we know that our car gets 31 miles per gallon. So we're going to take that 800 miles and we're going to divide it by our 31 miles per gallon. And I can't remember what that is, so let me grab my calculator real quick. 800 divided by 31 is about 26 gallons. Okay, since we have 26 gallons, we know that it's 350 a gallon, so we're going to take our 26 gallons and we're going to have to multiply that by 350 a gallon. And we end up with roughly about $90. So how much did they budget? About $90. Again, we could have set that up as a proportion, but understanding how to get the answer is a little bit more important. Realizing that we had our 800 miles, we chopped it into our 31 miles per gallon to get that 26. So the couple of things that we're going to look at here are those conversions like that, but then also setting up those ratios and then turning them into proportions to solve for a piece. So go ahead and get out your notes and vocab for this section. Objectives of this section is to compute unit rates, to use scale factors, and to solve real-world problems using ratios or proportions. Unit rates are what we did on that first one. 62 miles and 2 gallons, we wanted to convert that all the way down to 31 miles per 1 gallon. So 1 unit there. Using the scale factors is what we did on our map. We figured out 1/2 of an inch equaled 80 miles, so we wanted to see what that was in real life. And then solving our real world problems using ratios, which is what we did on all 4 of those. Okay, looking at the definitions. The comparison between the number of gallons of gas and the number of miles was a ratio. Again, a ratio is a comparison of 2 numbers by division. We can write it in a couple of different ways, x to y, miles to gallons. We could use a colon in between, or we can write it as a fraction, the way that we did. Remember, that's just comparing the 2 different numbers. As soon as we set that equal sign in between, we know that it's a proportion, an equation stating that 2 ratios are equal. So there we can actually solve. Okay, looking at example 1, we have to see that we have to figure out if these are 2 equivalent ratios. So we're supposed to write yes or no. Right, looking at these as fractions, let's go ahead and see if we can simplify them down to simplified form. 2/3 is actually simplified down. So I'm going to write 2/3 and I'm going to say that that's simplified. What I want to do is see if 16/24 simplifies down to that. If it does, then I know that I'm good to go. Okay, so I'm going to go ahead and look at 16/24. It looks like 8 goes into both of them. So I'm going to divide both of them by 8. 16 divided by 8 is 2. 24 divided by 8 is 3. So are they equivalent? Yes. They both simplify down to 2/3. Okay. Again, looking at equivalent ratios, and that's what we're doing on this whole section, is making sure that each side is balanced and equal. Okay, go ahead and try guided practice 1. Okay, these problems are getting us used to, again, realizing that numbers can be written in many different ways. So looking at 6/10, 6/10 simplifies down to 3/5. Since 2/5 is already simplified, we know that those 2 numbers are not equivalent ratios. 1b, 1/6 is already simplified. 5/30 does simplify down to 1/6, so they are equivalent ratios. Okay, a couple more vocab words here. There are special names for the terms and proportions. The 1.5 and the 1.2 are called the means. They're the middle terms of the proportions. The extremes are the extreme outsides, the 0.2 and the 9.0. Again, they're the first and the last terms of the proportion. The biggest thing to understand about this is this little table right here that says in a proportion, the product of the extremes is equal to the product of the means. The best way to look at this is to actually visualize that. So what that means is that you're going to take the denominator and the numerator of the opposite and multiply them together. And then you're going to take the denominator and the numerator of the opposites and multiply them together. So if those two numbers multiply together equal each other, notice what they did here. A times D is going to equal B times C. Again, they give a good example here. 4 times 1 is 4. 2 times 2 is 4. Okay, so this is kind of the X check. If the means and the extremes are equal, we do know that we have equivalent ratios. Okay, we do call that the cross products. So looking at example 2, instead of simplifying them down, let's go ahead and look at the cross products to determine whether they do form a proportion, if we could put an equal sign in between here and consider it true. So let's go ahead and look at this. We're going to take 8 and we are going to multiply that by 3.5, and we end up with 28. So 8 times 3.5 is 28. Now we're going to try that with our extremes. Our 2 times 4 is 28. So do they form a proportion? Yes, they do. Okay. B, let's go ahead and try it. Again, dealing with decimals, but as long as we have a calculator out there handy, we should be okay. So 1/2 times 1.5 gives us 3/4. 2 times 0.3 gives us 0.6, or 6/10. So could we put an equal sign in between here? No, we cannot, because the means and the extremes are not equivalent. Okay, go ahead and use those cross products to solve guided practice 2. Okay, neither one of those passed the test. Realize that 1 8/10, that decimal place was just moved once to get 1800ths. They are not the same thing, so that is a no, using those cross products. So looking at that and remembering those cross products, let's see if we can solve some proportions like that as well. We now have an equal sign in between. So we know that these two ratios have passed the test. We know that they are equal. So we're going to solve these by using those cross products. Well, those cross products tell me that the means and the extremes should equal each other, the products of them. So that means that 10 times 3 should equal 5 times x, which means that 30 should equal 5 times whatever that number is. Dividing that 5 out, real quick step right there, we know that x equals 6. Another way that some kids look at this, they actually say, okay, well, I see that to get from 5 to 10, I doubled it. So what's the double of 3? It's a 6. So do you have to use cross products? No, you can go ahead and look at that. One of the biggest things, though, is making sure that how did we get from the 5 to the 10? Do not say that we added 5. We doubled. We either multiplied or divided by a number. All right, B is a little bit different. It's a little bit trickier to look at that and figure out if we doubled or if we increased, if we tripled. Again, let's look at those cross products. They state that 14 times that 2, which is 28, has to be equal to the 7 times the quantity of x minus 2. So on this one, we actually have to do a little bit of distributive property because the 7 has to be multiplied by both the x and the negative 2. So now what we just did is we created a multi-step equation where step number 1, we're going to have to distribute that 7 through. So 28 is 7x minus 14. We know that we add or subtract first. So we end up with 42 equals 7x. Last step is to divide. So we know that x equals 6. Okay, cross products work a little bit better on B than they do on A. A, we can maybe quickly understand what that is. But remember, if we do have addition or subtraction operation in there, we have to turn that into a distributive property type of situation. All right, go ahead and try this guided practice using cross products or just filling in the blank with how did I get from 8 to 40. Okay, with 3a, I realized how did they get from 40 to 8? They divided by 5. So I'm going to have to do that same operation to get from 25 to whatever that number is. So 25 divided by 5 is 5. I could have used cross products. 25 times 8 is 200 equals 40 times the number, and realize that r equals 5. 3b, okay, again, cross products. 15 equals 8 times the quantity of x plus 4. Doing some subtracting, I realized that I get down to negative 17 divided by 8. The directions did say round that to the nearest hundredth. So final answer should be negative 2.13. All right, now we're going to look at those unit rates. It says the ratio of two measurements having different units of measure is called a rate. For example, a price of $9.99 per 10 songs is a rate. A rate that tells how many of one item is being compared to one of another item is called a unit rate. So again, the difference unit means we are just looking at one of those. How much is it per one song? And that's what we did with our miles per 1 gallon. We just wanted to see the unit rate of that. So looking at example 4, it says in the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer open in the next 3 years? Well, let's go ahead and figure out what the unit rate is. How many stores did he open in 1 year? So again, if we have 232 stores per 2 years, how many stores is that in 1 year? So we're going to have to take that 232. How did we get from 2 to 1? We chopped it in half. So what's half of 232? He opened 116 stores per year. Okay, let's go back to the problem now. Now that we understand how many stores per 1 year, it does say how many stores will the retailer open in the next 3 years. So we're going to take that 116 and we are going to multiply it by 3. So 116 times 3. In 3 years, he is going to open up 348 stores. Again, is that the only way to solve that problem? We could have actually just set a proportion on that one and solved it, but understanding that unit rate helps us out as well. All right, go ahead and try guided practice 4. Okay, it says that it takes Isabella 7 minutes to walk around the gym track twice, so she can do 2 laps in 7 minutes. It says at this rate, how many times can she walk around the track in half an hour? Well, I'm not going to put a half up there because we're looking at minutes up here. So another thing, make sure that all of your labels are coincide with each other, are the same. So I put 30 minutes there. Again, notice that I have minutes over minutes. 2 laps equals how many laps here? So instead of finding a unit rate here, I went ahead and created a proportion. So now I'm going to multiply cross products. I have 60 equals 7 times x. Dividing by that 7 then, she makes it about a little over 8.5 laps in half an hour. Okay, question is, could I have had laps on top and then minutes on bottom? Yes, I could have. Could I have actually compared minutes and minutes to laps and laps? Yes, I could have. Again, as long as straight across we have the same information, we should be good to go. All right, let's go ahead and look at these scale models. We should be okay with this one as well, because again, we worked on this on our map. It said that the Ramsey Cascade Trail is about 1 1/8 inch long on a map, with the scale 3 inches equals 10 miles. So what is the actual length of the trail? Okay, so again, I'm going to show you another way that we're going to do this. We're going to compare inches and inches to miles and miles. So we're going to compare the 1 1/8 inch of the cascade versus the 3 inches. Okay. We want to know, again, I'm going to keep this organized. If I'm dealing with cascades up here, I want to find the actual length of the cascade I don't know what that is. But on the scale, I know that 3 inches equals 10 miles. Okay, so a different way to do this, and I hope it doesn't confuse you, but I want to show you that you can set up these proportions a little bit different. But notice that cascade is straight across. I'm dealing with 1 1/8 inch in the piece I don't know. Then I'm dealing with 3 inches and the 10 miles that I do know. Okay, let's go ahead and do cross products on this. So we have 10, and I am going to pause for a second to get up the calculator so I can show you how to plug this into your calculator. Okay, do remember that unfortunately these calculators don't have that nice little fraction button, so I am going to write this as a mixed fraction. Okay, 1 1/8 is actually 9/8, and I do want to put parentheses in there, and remember that division sign actually gives us that fraction sign. So I'm going to take 9/8 and I'm going to multiply that by 10. Okay, so cross products there, 11.25. And I know that that cross product is going to equal 3x. Okay, last thing I have to do is go ahead and divide by 3. So 11.25 divided by 3. Okay, what is the actual length of that trail? 3 3/4 long. So we know that we have a 3.75 mile long trail. Okay, setting it up, please make sure that everything is equal straight across and you should be good to go. So go ahead and try this last guided practice. Okay, on this one I went back to going ahead and comparing the ratios like we had started with. 5 centimeters compares to 2 meters. We're trying to figure out what 28.5 centimeters compares to with meters. So again, I went ahead and did my cross products. One thing, don't get confused that our labels don't add up. This is not like dimensional analysis where we're trying to cancel out those. We have an equal sign in between. We are just comparing the means and the extremes. So 28.5 times 2 is 57. We are trying to figure out what 5 times the number equals 57. So our x equals about 11.4. We need to go back to the problem to understand what we're dealing with. We're dealing with meters. So the actual wingspan of our airplane is 11.4 meters. Okay, dealing with a lot of different types of ratios, proportions, unit rates, and scales. But as long as our labels are lined up, we should be good to go with this. So go ahead and try the assignment for this section.